Hi folks, so today we're going to have a look at this interesting looking Instrustar PC oscilloscope. This one's previously loved. I don't know if that's the right word, but got it off a friend of mine. He said he picked it up 10 years ago or so. I don't know if they're around then or not, but he can't really remember. He says he thinks he paid $50 for it. I looked them up. They're still available. I looked them up online and they're selling for around about $100 Canadian on Amazon.ca. So he might have been talking about the US price back a few years ago, and that would have been pretty accurate. So it's a pretty cheap scope. It's cheaper than anything else out there of this type. And I also get the impression it's made in Russia, because if you go onto their website, and it's right there, www.instrustar.com, you see that the software is available only in English and in Russian versions. There's no Chinese version, there's no universal version. You can select the language, and but it doesn't say anywhere on the box where they're made. We've got a couple of probes here. Let's configure them with blue and yellow stripes on them. I guess not all the accessories are here. We got a little screwdriver for doing the compensation. USB cable, which he's never opened. I won't be using it either, because I've got USB cables already on my bench here going to my computer. And here's the unit itself in a little bag. No software. I guess I'll have to go over and download it. Little bumpers on it. Unfortunately, they're not square on the bottom, so this thing won't stand up that way very well if you wanted to stick it into a little slot on your bench. So it has to lie flat. You got two channels. You got the little signal here, 2 volts peak to peak at 1 kilohertz for doing the compensation. A USB port at the back and a power LED. Okay, very simple looking. Let me get this out of the way, and we'll go and install the software. Okay, that was not too bad. So let's now plug this thing in and then launch the application. So we got the power light is on. Let's launch the application here. Okay, we're just going to choose the oscilloscope, spectrum analyzer, simplified. See how that comes up. All right. Well, let's hook up a probe, channel 1 there. Guessing that's channel 1. Yeah, channel 1. And we'll hook that up here to the compensation output. How do you tell if it's found the oscilloscope or not? Do that. Oh, okay, there we go. Oh, that's nice. I like that drop-down menu there. I hate these sorts of things. That's just pain in the ass. It's nice that they have the drop-down menu. Under here we've got more. We've got probe. Do I have it set to 10 times? I do. It needs compensation. AC, DC input, invert, vertical offset. Well, everything you really need for a basic scope is there. Let's see if we can do the compensation on this and make it look a little nicer. That looks pretty good. All right, so I'm just going to quickly have a look at what we do on the triggers. We've got auto, normal. I guess that adjusts the trigger there, so it shouldn't be triggering now. We go back up to auto. It should be drifting around all over the place. It is. bring the trigger voltage up. The user interface is pretty easy. None. So I guess it turns the trigger off. Rising edge, falling edge, and then either edge. I think that's pretty useless. Alright, and there's the level, which it's conveniently set like this. I like that. Or you can put in a value here, that's good. Trigger sensitivity, trigger front percent. I don't know what that means. Alright, let's just check out the bandwidth here. It's supposed to be a 20 megahertz oscilloscope. And we'll get my signal generator fired up there. These probes are they're rated over here. You look at this. We've got a decent amount of information on them. I don't know if any of it's correct or not. So 60 megahertz in 10 times mode, 6 megahertz in 1 times mode. They're not the nicest material. It is pretty soft. It's like a plasticized PVC. Reasonable junky probe. I guess this is the sort of thing you'd get for $6 or $7 on Fleabay or Amazon or someplace like that, or over on AliExpress. Alright, my frequency generator's up and running. Okay, so we've got it roughly at, I'll call that 1 volt peak to peak there. Let's see where we get up to 0.7 volts peak to peak. Let's just pop right up again to about, let's say 3 megahertz. Oh, look at the aliasing going on. That's pretty bad. Okay, so that should be right about here somewhere, right? Look at this. Look at the waveform. That's just horrible. Alright, 0.83 volts there. That's the 4 megahertz. 0.723. There we are. Oh gosh, look at that waveform. This is hilarious. So it really is more like a 4 megahertz scope, not a 20 megahertz scope. We're here at 6, but you know, while the voltage level is okay, the waveform is just absolute crap. So we go back to 4 megahertz. I think it's the last place where it looked reasonable. I can't even call that reasonable. So let's take it up to 20 megahertz and see what that kind of looks like. Give it a benefit of the doubt. Let's go over to here. So no, this is not a 20 megahertz oscilloscope with any stretch of the imagination whatsoever. Okay, let's bring it back down to 1 megahertz. Or at least the waveform is reasonable looking. I don't think this is sampling anywhere near the 48 megasamples per second that they claim. Alright, well the user interface is not that bad. The scope is pretty crappy though. And let's change the output to a square wave, see what that looks like. Yeah, well that tells you everything right there. Yeah, that's pretty bad. You can see the rising edge of it. It's just, you know, we go up in frequency here, well we get about 5 megahertz. Begins to look like a triangle. It's maintaining a bit more voltage here, but I think this just overshoot. And as we go up, it just falls apart. It can just look like a square wave again though. But I don't think I think that's an artifact more than anything else. That there it is at 10 megahertz. Alright, enough of this. This is basically useless. Let's pull it apart and have a look. Okay, they came off pretty easy. And it looks like we've got some screws there. I bet you if I just take off one of these covers, everything else will fall out. Let me get through it. Let's type over those. Well, there really isn't much to that. I'll stand here, get it up closer for you guys. Now I'm going to have to look at some of this stuff under a magnifying glass. It's a 24 megahertz oscillator there, or crystal, going into what is undoubtedly the CPU. It's got relays on the input. No shielding, but I guess the can will shield things. This will provide pretty good shielding. Let's have a look. Okay, so yeah, so what do we have here? These are 74 HC451 and they're analog multiplexers. So I guess these have got the chore of putting in the attenuation, switching in these different resistors. and both of these are the same, and they're being controlled by this. This is a 74HC595 shift register, which is probably just a port extension coming out of that, and it's also controlling these little relays here. And this here is actually a little bit of overkill. I mean, this is an 809288 dual analog to digital converter, and it's good for up to 475 megahertz. I don't know why they didn't try to run it a little bit better to get you know, real sampling and, you know, really get this thing to work at 20 megahertz, or help it get there. I don't know. This could be very limited as well. This is just a Cypress USB microcontroller. So there's not a lot of brains here. This here is one of those little 64-bit serial EEPROMs. I think it's a 24LC64. And that's all she wrote. A little 3.5 volt regulator here. I do not know what this black box is. No idea. But we do have on the bottom, we just got a few little bit of passive discrete components. Not much going on. So I'd imagine, you know, I would imagine all the triggering and all the intelligence is in the software, and maybe that's one of the reasons why it fails. It's trying to keep up with the data stream coming out of this and going through. And I had it plugged into a USB 2 port, so I don't know if that helps or hinders the situation. But yeah. So these come with other features. So if you look at the box here, there is this is the ISDS205A, and that's just an oscilloscope. So there's an oscilloscope plus signal generator and an oscilloscope plus logic analyzers. So I would imagine that these footprints here are for enabling the signal generator, the logic analyzer. I imagine this stuff here is for the logic analyzer and this is for the signal generator, or vice versa. So let's have a look. Let's, 1 sec, I'll be back. But this one here looks like it's strictly for the model with the signal generator, because this looks like it's another microcontroller here, and this looks like a ladder type analog to digital, or digital to analog converter with a small op amp here, and that's going out to this output here, which is just another BNC connector. This stuff here, this here is for some sort of external EEPROM programming, so that hasn't been allowed for on this model at all, and I don't see a model where it is allowed, so I don't know why they have that there. Maybe they just have a jig that comes in to do the serial EEPROM programming. I don't know. Also over here, this little pot here just adjusts the output of the compensation generator here. There's another little pot here. A couple of little, actually these look like little trimmer caps. Probably for just polishing up the front end a little bit. This here looks like the logic analyzer pin. So that chip here would be the logic analyzer if you have it. So this, yeah, this board will do them all. You could have all this populated over here for the signal generator and this for the logic analyzer. I guess you lose these 2 pins, but then you have a signal generator that you can use for your compensation. All right, that's it. Not recommended. You know, at $100, definitely not recommended. You can get better little handheld scopes than this with better bandwidth and far better displays, without having to tie up a computer to do things as well. So yeah, avoid this. It's not worth getting. You know, for $100, no. I mean, save your money. For around about $300, you can get a really good standalone Siglent oscilloscope. A lower end unit, but it'll blow the doors off this. It'll have 100 megahertz bandwidth, and it'll really have 100 megahertz bandwidth. Not something that comes in a box that says it has 20, yet it really practically only has 4 or 5. Yeah, thumbs down on this one. It's like all the other little tools that I've been showing you that are really, really cheap. Most of the time they're not worth it. All right, folks, stay away from it. Thank you for joining me, and we'll see you in the next one. Bye-bye.